In this video, I want to talk about motor protection. Okay, motor protection is extremely important because we have to make sure that we don't run into an overload condition on our motors. Okay, so motor protection in most of our refrigeration components are also called overloads. The overload does a couple different things, but the primary purpose is to shut down the motor circuit due to heat or high amperage draw. Okay, now the way the overloads are designed is that high amperage draw does produce heat. Okay, so as the amperage goes up, the heat generated by electrical components, specifically little resistive or bimetal heaters, does increase, and the overload will eventually pop open because it senses this heat. We also have solid state overloads that use the heat to increase the resistance of a substance so that sooner or later the resistance is going to increase enough that there's going to be no current that passes. We have different types of motor starters. We have some that are part of the motor starter package, the start components. Okay, we have some that the contactors is built-in overload. We also have overloads consisting of a ratchet wheel, solder, heaters, or springs. Okay, basically what happens in all motor overloads, the overload is activated by heater wire. Excessive current, which produces excess heat, melts the solder and the ratchet wheel opens in the contact. The heater is line duty and is in the main circuit. Contacts are pilot duty and in the control circuit. We have 4-wire overloads that consist of a current sensing coil and contacts. The 4-wire overload, the way it works, the sequence of operation is the coil senses amperage. Excessive amperage will open the contacts. The contacts are usually wired in series with the motor contactors, used primarily on 3-phase motors, also called motor starters and protectors. Bimetal overloads is a bimetal strip that opens or closes contacts. The commercial type uses a heater, and the heater and contacts may be in series or parallel. The domestic type, and it's not just domestic. I want to be careful about that because we also see these in commercial systems. They mount to the compressor. It may be bimetal only or bimetal with heaters. Now remember, when I'm talking bimetal, we're talking about two dissimilar types of metal that are welded together in a factory setting. And what happens as they heat up, it bends. Excessive current across any metal component will cause it to bend. Okay, the current flow and the unit temperatures combine to open the contacts. The contacts automatically reset. Overload is line duty, directly in the circuit. To size overloads, all overloads are rated by amperage and horsepower. Okay, all have normal amperage draws of 115% to 125% of full load amperage for a set amount of time. Now, why do I want this over full load amperage? It's because as the motor starts, we're going to draw a certain amount of locked rotor amps. We can't just have everything pop open right as it hits over the amperage draw. Okay, so we have to go for over the full load amperage, but we can't have it permanently at the full load amperage. So in other words, we have to give it enough time for the compressor to start spinning before we pop the overload open for an over amperage condition. So it's pretty important that we rate it by amperage and horsepower. Newer methods are solid state thermistor. Okay, a thermistor is something that changes resistance based on temperature. So as heat is produced, resistance changes and changes the current flow to a microprocessor or even to a PTC. Okay, information is received by the microprocessor, and in turn it shuts down the unit. So overloads, again, the purpose of the overload, to protect a motor. Okay, most of the refrigeration overloads you see until you get to big commercial equipment, I mean the type of equipment that takes a crane to move, most of the overloads you're going to see are going to be bimetal overloads or PTC overloads that are part of the start components.